Well, good evening to you all. Yesterday I talked about the chromatography, and today I shall demonstrate to you how we are able to make the distinction of the ingredients by using a term called as RF, the full name of which is retardation factor. So, this is, friends, the Wattman's paper. You can see this is the Wattman's paper, and this Wattman's paper is actually drawn a line almost 2 centimeters from the base. This is called as the base, and we choose the center of this line. And at the center of this line, we simply put the spot. I mean that mixture that you wanna identify by separating the ingredients off by chromatography. So this is the particular point, the midpoint of this line, at which you lay the spot. By using a needle or the capillary tube, you can spot this here. Then this base of the chromatogram, this is the chromatogram, it is put in the liquid, and the liquid goes up by the capillary action till it reaches here after 1 hour or so. So the solvent reaches here, and this is basically the level up to which the solvent has to let ascend or go up. Then we take it out and we dry it, and we mark this particular place up to which the solvent has ascended. This is called as the solvent front. And this is called as the baseline. So while we dry it up, we see that there are different spots. So some spots are here, some are here, some here, and some here. So all these ingredients that the mixture was containing, so those have undergone the segregation, and we mark these points with these circles. As I told you that it's not always necessary that all the spots will be visible, but we make them visible by spraying the chromatogram with some indicator solution or the spotter. Then you can see that each of these spots is stuck at a different place from the baseline. This one is nearest to the baseline, and this one is farther, this one is farther, and so on. So it goes on like that. The last one, it is here, and that is nearing the solvent front. Means this is the ingredient in the system which has not been held by the the chromatogram or the stationary phase as much as these have been held. So this is the most held one. This ingredient, it has been the most held one by the chromatogram, and all these are basically falling in the in the range between this one and this one. So now you have basically the solvent front and you have the baseline. So you simply take out the ruler and you see that what distance is between this spot and the baseline, this spot and the baseline. And all these spots have different distances from the baseline. Then we calculate its RF, and RF is defined as the distance in centimeters of a spot from baseline divided by the distance in centimeters of the solvent front from the baseline. This is the distance of the solvent front from the baseline. So this huge distance, you can see the distance from this particular point, the solvent front, and straight away towards the baseline, this distance. So this distance is remaining constant for all the spots, but their individual distances vary. And that's how we can get the RF factor for all of them. And from these RF factors, we can identify which ingredient is which. Basically, we have the literature available, and that literature has got the RF factors well mentioned and well documented for every substance. So you can open that book and you can see that which RF factor has been with you, and then you can identify against that the kind of substance that you have segregated from the mixture. This is the chromatogram, and this is the experiment that concludes here about the chromatography. So hope you have understood this. If still you have queries, you can SMS me or just call me to wipe out your confusions. Thank you. Have a nice day.